Well, welcome everyone for a very interesting and special Ask Tom series on JSON and PL SQL. And not only is this topic quite interesting, we also have a new member in the team. We were actually working together for many years, but now Julian joined Oracle. And welcome, Julian.
Thank you, Beta.
And you will be working on these areas of PL, SQL, and JSON. Maybe introduce you to our audience. Give a little intro of what you do and why you're here.
That is correct. So hello, everyone. Welcome to our STOM presentation. It will be delivered, as you can see from the slide, by me, Beta, Beethoven, and Ron. And I'm the new kid on the block here. I joined Oracle Corporation on November 1st. So tomorrow I start my second month. I'm still into my first month. I will be responsible, and I'm responsible already for PL SQL. I'm the product manager of PL SQL and also the product manager of JSON and relational duality. So everything JSON falls under me in terms of product management. I will let also probably Ron, Beethoven, and Beta introduce themselves before we start the real presentation. Maybe
Sure.
Beta, over to you.
Yes. So yeah, I will get Oracle on the JSON part. This is my Ask Tom, and the purpose of this meeting is basically a touch point with people to meet the team. And you heard from Julian; he's product manager for these areas of PL, SQL, and JSON. Very hot, probably, Julian. You can sleep 4 hours going forward. I work on the development team for JSON relational duality, and also text, XML, LOB, so many areas. And I've been working with Beethoven and Ron from the PL SQL team for many years, probably 10 plus years, I guess. So maybe over to you, Beethoven.
Yep. So I've been in the PL SQL team for, I don't know, gosh, 20, maybe a little less than 20 years, but certainly been at Oracle for a long, long time. First job out of college. And been working in the PL SQL team in different aspects, and now lead a fairly large chunk of the team that runs the language. We own the language and we own the debugger, and some of the other secondary aspects of PL SQL. And JSON is a very important data type in the language, and we really hope that this talk will help us understand how to push the language forward with JSON.
Okay, I guess I'm next. I'm Ron Decker. I've worked with Beethoven in PL SQL, like he said, for a long time, longer than I think probably either of us wish to admit. I'm a developer in his group. Beethoven is kind of our big guy. He's running the show, which is awesome. And I work on just all sorts of different things in PL SQL. But the last, couple of years, 5 years, it's been a big focus on JSON. And, we have big plans for JSON going forward. And, we'd like to just talk today a little bit about what we've done, in the past couple of years to support JSON. So with that, let's go forward, I guess.
All right, let's start. So over to Beta. Beta will tell us why exactly JSON and PL SQL. What is the relation? Why are we here?
Exactly. So on one hand, we talk about like a data model, on the other hand of a programming language. And initially it sounds a little bit like two totally different things, like strawberries and pizza. Why does that make sense? Well, strawberry and pizza may not make good sense, but JSON and PL SQL does a lot. So a quick like high level view at these technologies, like JSON, as you know, is great for schema flexible data management. You can store data as JSON. You can exchange data as JSON. And because it is schema flexible and it is one data type that stores many values inside, it allows you to decouple application changes from database schema changes. So this is one of the big pluses of using JSON for application projects. And we see like a lot of people using JSON, and not all of them know about the ability of having code run inside the database using PL SQL. So PL SQL is a programming language. And it is for business logic that is easier coded than declared. Like, what do I mean with that? Often you access your data using SQL, but then there are more complex operations, for example, loops or conditions. You want to use, you have an order and you want to calculate a discount on that order. And maybe that is quite complex to express with SQL, and it's much easier to do it with SQL because you can modularize things in functions, you can have local variables. So instead of having all that logic in your application, you can have it directly in the database. So it allows you to centralize and also encapsulate that logic in one place. And obviously, all the security rules are then consistently enforced independently of which application accesses it. If you have like different applications, let's say one in Java, one JavaScript, etc., then they would all have to support this kind of logic. So it's much easier and also faster to run it in the database. And I thought about like what could be a good use case or two use cases for a JSON developer to look into PL SQL, or for someone who is very familiar with PL SQL to take a look at JSON, because I feel there's both are developer groups. There may be an intersection, but the intersection may not be as big as we want it to be. And the example use cases I come up with is that if you're a JSON developer and you stored your JSON data in Oracle database because you are really a friend of this agile schema flexible development, then it might be quite interesting to have logic inside the database, for example, in terms of a trigger, like whenever you update or insert a document, you could use a trigger that performs some operations on this object. It could calculate some discounts, or it could validate that all data is correct, or it could log some things. So that's the use case for a JSON developer to start using PL SQL. And one example I could came up with is like a PL SQL developer, for example, could use JSON as a in-out parameter to simplify application evolution, where you say, hey, I'm communicating with my logic using JSON, and if my application evolves, I have like a V2. Well, there's obviously other ways to deal with that, but JSON is inherently schema flexible. So that's an interesting, totally new paradigm for PL SQL developers. And this was just like high level to motivate why the intersection is not empty. And I will hand it over to Julian to now look into the details. But again, this Ask Tom session is meant for the audience to ask questions and interact with us. So please put things in the chat or in the Q&A.
And we already have the first question in the Q&A. First question came from Sanjeev. He's asking if the JSON in-out parameter in PL SQL function is available in 19C as well.
It's not. So the functional capabilities can be solved in 19C. You would basically use a blob or a varchar or a clob to convey the JSON. And so you can work with it, but it's not a JSON data type. The JSON data type was added in release 21C, and but not in 19C. Okay, over to you, Julian.
All right, so let's continue. And let's start with PL SQL. So the presentation is divided into two, more or less. The first part will be about PL SQL, and then the second part will be about JSON. PL SQL is, of course, is the procedural language for SQL, and it is loosely based on Ada. And Ada is a programming language which is a variant of Pascal. It was developed a long time ago, especially for the needs of the US Department of Defense. And PL SQL has been in the database as a language since version 6. But the stored procedures, function, packages, triggers, they became only with version 7, which came in 92, if I remember correctly. And let's start with what is new around PL SQL related to JSON in the database in 23C. The first feature is the DBMS JSON schema package, and Vito will cover it.
Yeah, so we add a lot of JSON capabilities to release 23C, and one of them is support for JSON schema. And what you can do with this is you can obviously use JSON schema to validate your JSON data. So let's say you have a JSON type column and it stores purchase orders, and you want to make sure that a purchase order has an ID and an order date. So you can specify a schema very similar to XML schema, not as powerful as XML schema. So JSON schema does not have subtypes, etc. But conceptually, it's like an XML schema, and you can define how your data looks like. And if you do an insert, we will validate if the data is correct or incorrect. And in order to find out, in the case that it's not correct, there are packages, DBMS JSON schema, that, for example, validate data, and it tells you it's valid or not. And if it's not valid, it gives you an actual list of reasons what is invalid. So similar to a compiler, if you have syntax errors in your program and you try to compile it, you get like a list of errors back. So it's not only saying it can't compile. And this is what this isSchema_valid function does. And the other very, very interesting part is, independent of validation, is to describe database objects. So forget JSON type for a second. Just say you have a relational table like the M table, or you have a view, or you have created a user-defined type, etc. So if you want to find out what that database object looks like, you can always do DBMS metadata get DDL, or you can look at the dictionary views, for example, to find out for a table what are the column names and the column data types and the constraints. But with this describe function, we now give you all that information as one JSON schema. And hence, you are able from an application to programmatically introspect a database object and, for example, validate that an operation on it is correct, or you can automate the creation of the UI. So it really converts a database object into a JSON schema. If you have any constraints, like a not null constraints, or you have something like salary has to be greater than 100, etc., those get translated to a schema rule inside the JSON schema. So this is quite interesting, and I think we will see a lot of people making use of it. But it's kind of a building block. It's like a foundation to describe database objects, and we will learn how our customers are using it. So we do get some questions here. Sometimes in some JSON, we do not have a key name. Then it becomes very difficult to reverse JSON data. Other ways to handle. So we do also have, this is already present in release 19C, a capability called JSON Data Guide. And that introspects your JSON data, and from it basically generates a JSON schema from the data itself, not from the compile time information or of the DDL information, but from the actual data. And that would give you the key names. So you would know what's inside the key names. If you still don't know, or if you cannot use the data guide, you can also have like introspection methods in PL SQL. That's also available since release 12, I believe. So you can have, maybe we see that later if we talk about JSON element T, etc. But you are able to introspect a JSON object and say, give me all the field names, etc. Lots of question here, quite an active audience. Maybe for the sake of time, let's move on, Julian. And I try
Let's
to
move on and we'll
them.
answer them. Yeah, we can answer them at the end.
Yeah.
I saw an interesting question. No slides on the screen. Is it intentional? No, I'm sharing my screen. Can you see my screen?
I can see your screen. Yes.
I am sharing. So
yeah.
I think probably you can log out and log in and see if you can see the slides again. Yeah. All right, let's move on. We'll answer the questions at the end. There is Q&A. The next one is on PL SQL features. And let's start with the SQL transpiler. This is a new thing. It came in 23C. You can think of transpiler as a combination of compiler and translator, but I'll let Beethoven explain more on that topic. Beethoven, over to you.
So first of all, what is a transpiler? Fundamentally, what we think about is PL SQL and SQL are two different languages in the database, right? But they have a lot of things in common. Their type systems are very, very similar. In fact, PL SQL has a superset of the type system. The functionality is very similar. So if you have a built-in that's built-in functionality that's in SQL, it's going to be available through PL SQL. And of course, PL SQL can call SQL. So the underlying tension here, though, is that when you want to write in one particular language like PL SQL, how do you actually have it effectively execute in SQL? So you have something that has the power. I think I forget who said this, but fundamentally, It's the power of expression of PL SQL with the speed of SQL. That is fundamentally the idea. And if you've used SQL macros before, you're like, hey, what's the deal? This is very similar to SQL macro. But the main thing here is that when you have a transpiler, the transpiler is giving you the ability to write PL SQL, and whatever you write is transpiled in by the SQL compiler into the equivalent expression in SQL, right? So you write it in PL SQL. SQL basically says, I see what you're doing. You're calling this thing here, and I know how to do the same thing. I'm going to ask my friend PL SQL, and I'm going to transpile this PL SQL thing into the SQL thing, right? So you get the expressibility of PL SQL but you get the performance in SQL, because whenever you are invoking something in PL SQL from SQL, there is always a slight cost, right? And so if you can avoid the cost, but get the same expressibility, that's great. Note, one of the big things about the fact that you don't have to do this as a macro is, in fact, for the transpiled function, what you could do is you can test the transpiled function like you would any PL SQL unit. And then once you're happy that what your PL SQL unit is doing is exactly what you want, then you can have it be transpiled in SQL, and it's going to have semantically what you want, right? And that's very important from the user's perspective, because a SQL macro is fundamentally returning a string. And the hope is that string is exactly what you want to express in SQL. So that is a very big difference, okay? And the end result is performance, okay? And in fact, I think we have a small example right here, right? So if we could go to the next slide. So here, this is a little bit of a cooked up example, but you could see here you have total, effectively something like a total compensation, right? And it's less than manager. And you could see that you can express within total that the total isn't quite n plus n, but you could say, length, right? Which is something that is both in SQL and PL SQL. You could take the length of n and then add the answer, which is the sum of n and m, and then return that. So this is a little bit of a cooked up example, but you could see that you could do something very interesting within the function itself. Okay, and that's an example of the transpiler in action, right? The transpiler is new in 23, and we expect it to evolve and become fairly rich in the future. Okay, that's it.
Thank you, Beethoven. And just to add, probably it's worth mentioning that the SQL transpiler in 23C is not enabled by default. There is a parameter, as you can see on the top of the slide, called SQL_transpiler. You can set it to on, the default is off, and you can set it on session or on system level. It's a dynamic parameter.
Yep.
Right, Beethoven? And this works only for functions for now, right?
Only for functions now. Yes.
Only for functions. It's important to mention that it works for functions only, not for procedures. Yep. All right, thank you, Beethoven.
Not for packages, actually. That's the number one thing.
And not functions which are in packages.
Correct.
Right. All right, let's move on. There is a new Boolean type in 23C, and related to the Boolean data type, there is again a new initor SP file parameter called PL SQL implicit conversion bool. And again, the default is false. If we would like to allow Oracle to implicitly convert Boolean values or any values related to Boolean, then we need to set it with the parameter as shown on the screen in the middle. And I want to show you an example of how it works and what it can do. We create a table called DBAs. You can see on the middle of the screen the creation of the table. We have an ID, which is a number. We have a name of the DBA. We have a Boolean column, is ACE, Oracle ACE. You probably are familiar with the ACE program at Oracle. And we have a last column, which is the number of certification that the ACE, so the person in the table, owns. And you can see, for the sake of the example, I insert 9 different values. You see some are database experts, ACEs. Some are football players. So, of course, football players are not ACEs and they have 0 Oracle certifications. And it's also worth mentioning that you see how I'm doing the insert with one command. I'm not doing 9 separate inserts and then committing at the end. In 23C, it is possible to do a multi-value insert with just one insert statement. And now How does it work? So if we want to convert numeric data type to Boolean, then anything which is non-zero is converted to true. And zero, the numeric number zero, is implicitly converted to false. If we have characters, so characters which are true, T, yes, on, and those are case insensitive, they will be converted implicitly to true. And if you have the opposite, false, F, no, and off, I mean the opposite of the characters above, they will be implicitly converted to false. If we have a number data type, so if we have true, it will be converted to the number 1, and false will be converted to number 0. And on the opposite side, true, of course, is converted to the character value true, and false is converted to the character value false, in quotation marks. Let's see how it works. Let's see from the table that we have. We are selecting the name and the is column. You remember that we did not translate, we did not insert the values always as true as false. We used the word T or on or true. And when you implicitly have the parameter set to true, Oracle always will show it as a Boolean value true or false. Here is the example. So let me go back again to the previous slide so you see how we did it. Look at the insert statement. For some it was Y, for some it was no, for some it was false. Once we do the implicit conversion, we get the Boolean values true or false. That is how it works. Another new feature of PL SQL is the extended case control. And I hand over now again to Beethoven, who will cover the feature.
Beethoven, you have to unmute if you're talking, or speak very loud.
Sorry. Okay, can you guys hear me?
Yes, we can hear you.
Yeah, so we're running a little late, so I'm going to try to speed through this because this is really late. We wanted to extend the language with new case controls, and if you go to the next slide, actually, so we can speed through this, you will see that we actually have the dangling dangling case expression. So you can see here the ace points here up there, and then in each of the when clauses, you can see that we have we can have the less than, the between. So basically, the value of ace points is evaluated once, right? And then you can compare to each of the values there. This expressibility is called the dangling predicate, right? So we provided this capability, and it's available for in 23C. This is something that I think is part of NC, and we've actually provided it in PL SQL. Right? Fundamentally, this is it, and it's a really nice expression that we provided in PL SQL.
Thank you very much, Beethoven. And it's worth also mentioning that the predicate is JSON is still not supported. So the dangling predicates is JSON and is are not supported. This is the last bullet point. I will quickly show you how this works in SQL Developer. I'll stop sharing now for a second, and I'll share my SQL Developer screen. And
by the way, there are some questions for this transpiler stuff.
Yeah. Let's you can ask them while I'm switching the screens.
Yeah.
Okay.
You can answer them. Try to answer.
Or just type them. I think it's
is there any overhead in? I think the one question that I really like is there any overhead in enabling? Fundamentally, the cost here is that you have a little bit of compilation work that has to be done for transpilation, but that's a compile time cost. It's a one-time cost, and really it shouldn't be that much. So let's see if there are any other questions. Any reason why it is not set as default if it can avoid context switches? I think that is fundamentally the goal. I think, but as with these kinds of things, the proof is always going to be in the pudding. So you're trying to be a little bit careful, right? Does extended case control work in SQL 2? It doesn't go that far, and that's actually part of the. You can imagine in our head that's what's in our head in terms of our roadmap, right? PL SQL and SQL to some extent we want to create the continuing illusion that they're really one language, right? Even though they're not.
Thank you very much, Beethoven. And here I have the same block, the PL SQL block, where we are using the dangling predicate. In the ACE program, if you have more than 275 points, I think you become an ACE director. So in the case statement, of course, since the points are 300, we expect, of course, that the candidate is an ACE director, and that's how we run it with using dangling predicate. So when greater than 274, this is the dangling predicate, we have as a result that the candidate is an ACE director. This is an example of how it works. I'll stop sharing and then I'll share the presentations again and we continue. All right. I guess now you can see the screen. Is it visible?
Yeah.
Yes.
All right. Very good. So JSON, short explanation about JSON, and before we go into the new features in 23C, worth mentioning that JSON appeared about 20 years ago as a result of the issue that web browsers had. They were using, if you remember, either Java applets or Flash, which were heavy, and developers were trying a way for easier communication between the client and the server, and that's how JSON appeared. And the name JSON stands for JavaScript object notation, but there was a second option when the language of the notation was created. It was JavaScript markup language, and the two were voted, and the JSON object notation was chosen over markup language. And I think it's for the good, because imagine if we have to say now JSML, would be much more complex. And of course, it's more of a notation than a language, so the choice was good.
JML or something, yeah.
Yes, and the built-in data type in Oracle has a maximum size. It is 32 megabytes, which, for example, compared with MongoDB is double the size. In MongoDB, I think it is 16 megabytes, right, Bida?
Yeah, that's right. I mean, we made it 32 because Mongo had 16. If Mongo had 128, we would have made it 256. There is no technical reasons to limit it to that size. It's more like preventing users to not shoot themselves into the foot. It's generally better practice to store many small to medium-sized JSON documents than to one or few very large JSON documents. And the reason has to do with parallelization and also indexing, etc. If you have an index that points at a 1 gigabyte JSON document and you look for something inside, then you still have to go through it. So I would say 32 megabyte is way beyond what people should be using. Maybe 3 megabyte is already too big, but there is a limit. And we have had people ask to go beyond it. But anyhow, it's yeah.
Thanks, Bida. And in 23C, there are 25 different data types. And every data type has a code. Just a funny note that JSON's code is 190. And I don't know if anyone knows that. But also, in order to use JSON in the database, you need to set the initORE parameter compatible to at least 20 when using it. And of course, there is other data types that support JSON besides the JSON types of varchar, to clop and blop, CLOP and BLOP, and those can be used even in 19C. All right, so over to Bida, who will cover now the JSON constructor and the JSON value support for PL SQL aggregate types.
I think we wanted Ron to do that, right?
Ron, sorry, correction. Yes, correction.
Yeah, that's all right.
Not a problem.
Right. Well, we get confused a lot. So, all right. So in PL SQL, what we did was to support JSON, we allowed our JSON constructors to now take what we say are PL SQL aggregate type instances. And I'll go back to that, and return a JSON object or array populated with the aggregate type data. And what that means is JSON constructor can now take a PL SQL record type instance. It can take a collection type, so an index table, or any of the SQL types that can be represented in PL SQL, which includes SQL objects, includes nested tables and V-arrays. So the JSON constructor can take an instance of any of those types, and it will generate the equivalent JSON for those types. And we'll see an example of that. Conversely, I guess the built-in JSON value now supports PL SQL aggregate types in the returning clause, mapping from JSON to the specified aggregate type. So again, by aggregate types, we're just talking about complex object types, record types, collection types, and those can be used in the returning clause of the JSON value built-in function, and that will, convert your JSON back into the PL SQL type. So effectively, we have a round trip, right? You can go from PL SQL type into JSON and then back into PL SQL, for example, right? So all PL SQL record type and collection data element type constraints are honored, including character max, length, integer range checks, not null constraints. Essentially, that just, we don't allow you to violate the data integrity of your PL SQL types, right? That's all that's saying. When we convert JSON into PL SQL, we're not going to let you insert a number that violates a length constraint or range constraint, for example, right? That should be expected. SQL objects and PL SQL record types, including implicit records created by row type, are allowed as input to the JSON constructor. And that's just all of our types, all of our complex types are allowed, is all we're saying. And the row type is interesting. Percent row type, people may not know under the covers, when you create a row type, which can be done on a table, you can have a table percent row type, you can have a view percent row type, you can have a cursor percent row type. And that just says under the covers, PL SQL is going to create a record. It's sort of an implicit record that represents those types. So, a percent row type, table percent row type in PL SQL will have fields that map to columns in a table, for example, right? And so an interesting thing there is if you do a PL SQL table percent row type variable, right? You have a variable, you could actually in PL SQL say select star into that variable from the table, right? Just populate the variable and then take that and give it to JSON constructor. And now we can now we have a representation. We have that table in JSON in PL SQL, right? As using the JSON constructor. And of course, the same goes with JSON value. You can have JSON value now. You could take that JSON that you just created from the table percent row type, pass it to JSON value, returning table percent row type. And you can, turn the JSON back into the record. So it's all about this sort of round tripping kind of stuff.
So Ron, let me ask you this question. If let's say I'm a PL SQL developer, I wrote something in PL SQL that is in production, but it's been written 10, 15 years ago and it works flawlessly. But now my management asked me for modernization. They want to use REST and microservices. Well, it sounds that I can use this existing code that was written long, long time ago and maybe write a wrapper or make some very minor changes. Just convert these states of my types or values to JSON, expose them to some sort of thing that just moves them over REST. And if a response comes back, I just use the inverse. So it sounds like I can very easily modernize an existing app with this. And you have to re-implement it on top or do the mapping outside the database with a lot of Java code. So this sounds like a couple one-liners basically, and I'm in microservice land with my 15 or 20-year-old code.
That's right. That's exactly the kind of thing we had in mind, Veda. And in fact, it was really the language driver folks really wanted this for that very kind of application, right? So you've got, your Python, your JavaScript, whatever, running outside the database, and you want to communicate with an existing PL SQL application in the database. This is an obvious way to do it, right? You pass in the JSON, like you said, a couple lines of code, you can map it, back and forth from PL SQL, and to PL SQL, and communicate just through JSON into an existing PL SQL application. So yeah, that was the big idea. And in fact, this last bullet point is kind of, saying exactly that. These are input streamlines, data interchange between, we could have said, existing PL SQL applications and languages that support JSON. Cool. Right. So that's you hit it right on the head. One more thing I just want to mention with the JSON constructor, when we take the PL SQL aggregate type, as you might imagine, we have to sort of generate the JSON, from scratch using the PL SQL type. And so there is a specific mapping at that level of, PL SQL to the JSON that is returned. And in the case of records and objects, PL SQL records and SQL objects that we map, you can imagine that the output JSON is going to be an object, right? It's going to be an object. One thing we did with index tables, though, if you give an index or pass an index table to the JSON constructor, we wanted to preserve the holes and the indices in the index table. So we actually map index tables to objects as well. And the object itself, when it comes out, you'll see the indices as the fields in the object. So, right, they can be negative, or they'll be missing or whatever, but that way it's all preserved. And again, with round tripping, you take that same object and you convert it back into an index table. You'll get the equivalent index table, right? You'll get the same indices in your index table, if that makes sense. So, that's maybe a little different. We also have associative arrays in PL SQL where the index is a varchar 2. So it's an index by varchar 2 collection. And those also, of course, will map into JSON objects where the key name becomes a field name, say in the JSON object. So maybe we can look at some examples from Julian.
Absolutely. Yes. Thank you very much, Ron. So let's move on and let's see at some examples. So let's see how we can convert first JSON to PL SQL, and then we'll see how we can convert PL SQL to JSON with some very simple examples. So this one shows how we can use JSON value to convert a JSON string into PL SQL. And look first at the declares part of the PL SQL block. We have a type. We call it pseudo table. And it is a table of numbers. So it will be using numbers. We index by POS integer. So for those of you who have been using also binary integer, POS integer, they are now exactly the same. There is no difference. But in the past, when they were created, one was using binary arithmetics and, machine arithmetics, and another one library arithmetics. But for now, there is no difference between POS integer and binary integer. So we define a power table called pseudo table. And the whole logic of the mathematics we're doing here in this conversion is that we have a number from 0 to 4, and we try to calculate, of course, the power of every number to itself. So 0 to the power of 0, 1 to the power of 1, 2 to the power of 2, 3 to the power of 3, 4 to the power of 4. And we have a JSON file. You can see what it looks like. Of course, it's pretty simple, but the idea is that using the JSON value, we can return the pseudo table, and by using the putLine function, the putLine from dbms output, we can we can print it in a PL SQL way. So this is the way to convert JSON into PL SQL. And of course, we don't have to use consequent numbers like 0, 1, 2, 3, 4, 5. They can be negative numbers. There is no order in the sequence, right, Ron?
Correct.
Correct. So this is just an example. We could have started with -2 and then have 4 and then have 7.
Right.
So anything else you want to add, Ron, to this example?
No, I think that was the main
All right.
thing I wanted to point out.
Then let's go to the other one. Here we can convert JSON, a PL SQL to a JSON string. So we create, of course, a pseudo table. Again, the same way we define the type pseudo table, table of number indexed by PL as integer. And the power table is based on the type pseudo table. We define a variable power JSON with the JSON data type. And into the index tables, the PL SQL table, the first we insert 1, then the second is also 1, then the third one is 4, the fourth one is 27, and the last one is 256. And then we use the JSON function to convert the power table into JSON. And we use again dbms output put line, which produces the JSON file. Very simple example how to convert a index table, a PL SQL table, into a JSON file. You can do it with a PL SQL block. Very simple. Mm-hmm. Any questions on that one, or comments from Ron or Beethoven or Bida?
No, there's just one question in general. Like everything we talk about here, does that run on autonomous? For JSON, I can say yes, but for PL SQL, I mean, these mappers, I'm pretty sure too, but the transpiler, does that work on autonomous?
I think the question there is this available on the release that autonomous is based on?
Is autonomous? Good point. Is available? Is 23C available in autonomous? I guess it's 19C now what you can provision.
Yeah. Yes. Okay.
And we're talking now about.
I missed that. Yeah, our autonomous fleet is 19C based. They're not on 23 yet, but in general,
it should, right? Once it moves to 23C, everything should work as here.
Yeah.
All right. And then there is one more example. This is a JSON constructor and JSON value support for PL SQL aggregate types. So that's another simple example how to use JSON serialize to convert or transform in a nice way a PL SQL aggregate or index table, a PL SQL table, into a JSON file. And again, we define the same type pseudo table and here we use row type. So you remember the DBA table, DBA row type. Here I have the output from the DBA's table. And we define a variable called DBA JSON, which is a JSON data type. And we do a bulk select into the DBA table, into that pseudo table. And then we use JSON to convert it. And then we print it with put line. And we use the pretty keyword. So here it is just an output of what it looks like. But maybe it's better if I move to stop sharing and I move to SQL worksheet and I show you how it really works. Give me a second, please. All right, and I'll share my screen now. Let me know when you can see it. Is it visible?
Yes.
Mm-hmm. Yep.
Okay. So here it is exactly the same PL SQL block. We define the pseudo table as DBA's row type, what Ron mentioned, and exactly as I explained, we try to run this and generate the JSON file. So here it is. Let me show it in a bit better way. So here it is. You can see what the JSON file looks like. It starts with Alex Zabala, who is, I think, in the call, goes for Radu, Osama, Robert, Simo. Simo is also on the call, as far as I know. And then with the football players who are not ACE directors. So that's how it works. All right, so I'll stop sharing again, and then I will continue with the PowerPoint presentation. Share my screen once more.
Yeah, I particularly like that final example because it shows the data flowing from SQL all the way out into JSON and then back out into
Yeah.
the client. It's a very
Yeah.
nice example.
It's
And
a very
this
simple example.
23C, right? There is a question whether this works on 19C without JSON data type, but that is not the case, right? This is 23C.
No,
Yeah.
it only works in 23C.
So you can code it with your own logic because we do have support for JSON in 19C using JSON element T. I put like a link there.
Mhm.
So you could code the same logic, but it would be a couple lines of code instead of just one line. Yeah.
Yes. All right. And then what else is new beta in 23C around JSON? Would you please cover those new features?
Yeah, I will go over this quickly and for time reasons. So I already mentioned JSON schema. I'll skip that. There is what is that? JSON type convertible check, DBMS JSON premier checks. Oh yeah, this is if you migrate. That's a good point. So that's a convenience method. If you migrate from a older Oracle version which does not have JSON type, and you upgrade to 23C, we recommend that you convert your text JSON storage, your CLOB or blob, to a JSON type. And as you learned before, there is a limit of 32 megabyte. So we would check that your data is below this limit. There's also an oddity with JSON that it allows duplicate key names. It's really stupid. So you can have something like, I have a person whose first name is Julian and Beta, like first name equals Julian and then first name equals Beta. I think it's plain stupid that that you have these contradicting values, but JSON text allows it. In our documentation, we basically said, don't do it. You won't get whatever you get. You don't get a crash, but you may get the first value or the last value or whatever. So we would flag this. We would say, hey, your data is kind of dirty. We don't want to silently omit values. And for this, you can run this check. There's also something done in Autorest. This is Chris Rice's team to support JSON duality views in 23C. So to describe it, I'm not, probably you want to attend their Ask-Tom to find out this. For check constraints, I mentioned earlier that you can convert database objects to JSON schema, and that includes tables, and tables can have constraints. And if you add a constraint, you can add this pre-check keyword that makes sure that the expression in that constraint can be converted to a JSON schema. So JSON schema is a bit less powerful than a SQL expression. So for example, in a SQL expression, you can call a PL SQL function. So the rules are unknown. It's kind of a black box. So we could not convert that to JSON schema. But with SQL expression, you can also say things like, okay, the bonus has to be less than a salary as a SQL expression, and this is not expressible in JSON schema. So by adding this pre-check keyword, you make sure that the SQL expression is convertible to JSON schema. And there are enhancements to the JSON search index and to the path language. So in general, there is like many enhancements made to JSON capabilities in 23C. So we could probably talk the rest of this Ask-Tom series on that, but I just shut up for now. So.
All right. And then we are very much at the end of the presentation. There are very few deprecated and supported features. So from Oracle 12.1, the parameter PL/SQL debug is deprecated. If you want to compile PL/SQL units, if you want to debug them, then use PL/SQL optimize level equals 1. And good news is that in 23C, no features in PL/SQL have been supported. You can see on the top left side a screenshot of the initOR parameters related to PL/SQL and to JSON. Those are the normal parameters. We're not showing the underscore parameters. And we have here a screenshot of what support would look like. So it's good to know that there will be 2 years of waived extended support, which will finish at the end of April 2026, so almost 2.5 years from now. And it's probably more interesting to know how 23C support would work. It is a long-term release, so there will be support until 28 and then extended support for another couple of years. So until 2031, there will be extended support. So this will be the next long-term release after 19C. And I think now we are done with the presentation with the slides. I think Ron, Beethoven B, that we can move to the Q&A session. We have 5-6 left.
Sure, absolutely.
All right. So question. There is a question from Niels Hecker.
Yeah,
says,
this is JSON table. I just replied to it. This is like a long-standing requirement. We are working on it. There is like a transaction that fixed it, but it did not made it into the first 23 version. I would be moderately optimistic that it will show up in 23. Maybe not the first version. I mean, this is generally like what's happening with 23 is what I call like, this is now unofficially like developer says something and don't write it into a legal contract. Like all the PMs, they know all the legal stuff that they're supposed to say and whatnot. We developers we're too stupid to know that. So I'm taking a little bit of leeway. So the thing is, I would call our current model continuous delivery. So we are adding capabilities. So for example, JSON duality views 23.2, 23.3. We're already a lot of enhancement, and 23.4 will have even more enhancements. And that is kind of the model where new capabilities show up in these hot areas. So if something does not make the first version of 23.x, it does not mean that it's not that you have to wait like 10 years for the next release. So for that feature that Niels asked for, JSON table enhancement, I think it'll be there. But again, no legal binding contract here. But a lot of people have asked for it.
Yeah, and I saw
it's a little bit like the problem with it. It looks easy, but it's a little tweak on the semantics of the path language, and there we have to just see how we best do it. But we hope we can do it without a new engine.
Thank you, Bida. And I saw a humorous comment that Italy is on Africa, but in the same way Madrid is in the Atlantic Ocean. It's just because there are so many now data centers in Europe that the map is so small that we need to place the names of the countries outside Europe. Otherwise, they will not fit into that small portion of the slide. All right. Any more questions? I see at the moment we have no more questions.
Yeah, this is now your time to ask questions, put them into the chat, or give feedback or things that you would like to see.
One thing I forgot to note, by the way, the PL/SQL language has also been updated with iterator control, and I think that's a feature that I think my apologies, I should have really pointed out. This is a very nice feature where we have significantly nicer iterate control syntactic sugar in the language, and it actually melds very well into the language. And I'm actually kind of curious to see what sort of constructs people will use with that syntactic sugar. But that's perhaps a discussion for another day.
Good point. Thanks, Beethoven. And there is a comment also I see from Sanjeev who says that it would be great if we can provide more examples in the documents, which make it easy to adopt and understand the function. And that is the plan we're having here with Bida and with Ron and with Beethoven. We are going to add more examples.
Yeah. Yeah, there is a conceptual, like in the doc, it's always like the doc has to be complete and obviously accurate. And sometimes that makes the doc quite lengthy, so that people, if they want to say, hey, how does JSON table work? They often, like, it's the way I personally use products very often. I take an example and then I copy paste it and then it runs, and then I modify it to do what I want to do. But that's just one model. Other people read the entire specification and then write a statement from spec. And I think the doc caters to the latter and not to the example modifiers like me. And it's hard to do both in one doc. But I get it. Me personally, whenever I look for how do I create like an ASM table space, it's like I don't read like 25 pages on the Oracle doc. I go to like some of these Tim Hall, or that kind of condense it. but they don't have to be complete, right? They kind of can just limit it to the relevant stuff. So yeah.
Yes, absolutely correct. Yes, very often learning a new feature is easiest via an example.
Yeah.
Right.
Yes.
Right. Let's see if we have more questions. There is a question from Michael Franson who says AI support to construct duality views from table or vice versa, create table definitions from JSON. Maybe the question means, is there an AI support to construct
that's coming. That's coming. Something like, well, it's not AI. It's, well, these days everything is called AI. So yeah, it is AI. But we will work definitely on utility tools that actually in this case it is, you can take your JSON data from, let's say, a JSON document store like a MongoDB. We analyze it. So this is like a new feature coming. So I'm not, anyways, we look into that. It's all about simplicity for JSON duality views, and JSON duality views have this initial step of creating the tables and the views on top. So there's this normalization step. And we understand that for some developers, this is cumbersome, and we work on tools, AI tools. I have to learn to, anyway, to make that easier and automatic. Yeah.
And I see that Beethoven is answering the question on any live labs.
Yeah, so I wanted to answer this actually more live. So I think the question there to Alan is, are there specific topics for live labs that you're thinking? Are you, for example, talking about what do you want us to elaborate a little bit more on this one with more examples for JSON being used in PL SQL, for example? Right?
There's one question also on JSON duality views, which we did not cover a lot here, but it seems there's a lot of interest. So maybe we can do one of the next Ask Tom on duality, Julian.
I think that's a very good idea, because duality view is a broad topic, and we need probably another 1 hour to cover it.
Well, let me try to answer this question quickly. So it's the point is very valid. So it's saying like PL SQL procedures mean that business rules are controlled in the database layer. Yes, it's one place, it's central, and it's consolidated, and all the security rules are enforced. But then it says, it seems to me that JSON duality means business rules are validated outside the database. This is an example where continuous delivery applies. So you will see in 23.4 that there are new means to add rules to duality views as well. So there's a brand new concept there. And the goal is, so one of the goals of JSON duality views is to replace ORMs. Today, if you use an ORM like Hibernate, it is very often only working for one language, for example, Java. And it means the logic is outside. And with duality views, one of the goals is to really provide the functionality of an ORM, but you do the object relational mapping inside the database. So you only have to do it in one place, and then it doesn't matter from which language you access it. And that obviously means that you want to also run business logic inside the database. So yes, that part is definitely very high on our radar, and it's coming.
Yes. All right, we're on top of the hour. We would like to thank everyone who took part in the presentation, and thank all.
There will be a recording also. There's a question, will there be a recording? Absolutely. We will cut it and then upload it, so you will be able to see it.
On YouTube, right, Bida? It will be available on YouTube.
Yeah, it's on Ask Tom as well as on YouTube.
Okay.
Yeah.
To answer Alan, by the way, as before he gets back, but the question, I guess, is: are there already live labs in the JSON space today that he can?
Yeah, everything has a live lab. Everything is a live lab. So I don't know how much you have for PL SQL on live labs, but if you go to live labs and you look for duality views, we have examples for PL SQL, for Java, for REST. There is stuff on storing JSON, etc. So everything should be covered with live labs.
Cool.
All right. Thank you very much, everyone. And we conclude now the presentation, and have a good day.
See you next time.
See you next time. Take care.
Bye.
Thanks,
Bye.
everyone.
Bye.